So now we're going to look at solving log inequalities. And the first thing we're going to do is always think about, hey, what are our domain restraints? So if I look here, I have 2x. So I know that that 2x has to be actually greater than 0. So I'm just going to write that off to the side here. I know that 0 has to be less than 2x. And this is what I mean by the extra step when we have a less than symbol. So the second thing I want to do is I want to look at this and write it in exponential form. So it will be 2 to the second power and usually we'd say like 2 to the second power equals 2x, but this is an inequality. So we're going to say that that 2x is actually less than 2 to the second power. And we're also going to put that other restraint that 0 has to be less than 2x. So now I have a compound inequality. I know 2 to the second is 4. And then when I solve it, I get 0 is less than x, which is less than 2. And I can put that in set builder notation there. So my x value for this inequality has to be 0 is less than x, which is less than 2. For problem 2, we have log functions on both sides of our inequality. Again, there's a less than symbol, and we want to make sure that we do that extra step of looking at the domain restrictions really well here. So I'm going to go ahead and look at my domain restrictions first. I know that, and I'm going to write this a little differently so the variable's on the left. I know that the value of 3x has to be greater than 0. And I know that 7x minus 8 also has to be greater than 0. So when I solve that, I get x has to be greater than 0 here. And here I get x has to be greater than 8 over 7. Now if you picture the two of those inequalities on the same number line, you'll notice that the overlap starts right here. So this is the inequality I'm going to be paying attention to because that's where they both would be true. Now, let's go back to the actual inequality here. Since we have the same base, we're going to take that and we're going to write 3x is less than 7x minus 8. I'm going to subtract 7x. That does give me a negative, but we know the rules for dividing inequalities by negatives will be okay. Divide by negative 4. Again, reverse that inequality symbol. So we have x is greater than 2. And x is greater than 8 over 7 now. When you picture these two graphed on a number line, which one would be where they have the overlap? I just noticed I forgot to close my set builder here. Here at x is greater than 2 is where both of those inequalities would overlap, the and portion. So that is what I would write in my set builder. In order for this to be true, my x value has to be greater than 2. So number 3 here, again, log only on one side. So we're going to look at that 3x plus 1, and it's greater than this time. So because it's greater than, we don't have that extra step of looking at this 3x plus 1 has to be greater than 0. So what we're going to do is we're going to write the 3x plus 1 down. And then we're going to write 2 to the 4th power. So I'm going to do 2 to the 4th, which is 16, and subtract 1, which is 15. Divide. And we get x has to be greater than 5. Notice any value greater than 5 will make this domain greater than 0. So this will be our solution, x such that x is greater than 5. Go ahead and try setting up number 4. So hopefully you're thinking to yourself, all right, it's greater than. We don't need to worry about setting 6x to be greater than 0, and I'm going to write the 6x down here, and then I have 27 to the 2/3 power. And I want you to think back, 27 to the 2/3 power. Well, 27 is 3 to the 3rd, and then that's also raised to the 2/3 power. So what do we really get there? 27 to the 2/3, or 3 to the 3rd to the 2/3, is actually 3 squared, or 9. So I'm going to write 9 down right here. And then I'll divide both sides by 6 and simplify that fraction to get x has to be greater than 3/2. Why don't you pause the video and try going as far as you can with 5 and 6. I'm going to do the first step just to see if you got that, and you can check that out, and if you did, you can keep going. So again, I just did those first steps for 5 and 6. For number 5, again, you have that extra step to look at. You're going to say x plus 3 is greater than 0. So I wrote 0 is less than x plus 3, which is less than 3 to the 3rd. Number 6, it does have greater than, so we don't have to put that 0 as less than, but we do need to make sure we check out our domain restrictions just as well. So for now, I wrote that x plus 3 is greater than 2x plus 1. So if you haven't yet, please solve number 5, written as is, and then number 6, you have to do this part here, and then the domain restrictions, and you might have one inequality in the end, you might have a compound inequality. So pause that, try it out, and we'll check out, see how you did. So here we go, we have for 5, x such that -3 is less than x, which is less than 24. And then for 6, when I did my domain restrictions, I get x is greater than -3, x is greater than -1/2. Where's the overlap starting? Here at that -1/2. And then I had to reverse my symbol, and I got x is less than 2 here. So my compound inequality is -2 is less than x, which is, I'm sorry, -1/2 is less than x, which is less than 2. So that would be my solution for this log inequality. So just to recap, for log inequalities, you do have to still take into consideration your domain restrictions, because your domain for logs has to be greater than 0. If you have a less than symbol, like number 1 and 5, just quickly for reference, you have to make sure you put that 0 here when you're solving those. For 3, we didn't have that, so we didn't have to worry about that. But we did double check to make sure that values for x greater than 5 made our domain work. And then if we have the same base on both sides, we just pull those out and solve the inequality, but again, check for those domain restrictions. Hope you do well. Feel free to email either of us if you have any questions. Take care.